What is up, everybody? I'm back with my third tutorial in R today. We'll be going over NBA data and soccer football data, specifically Premier League data. Um, and yeah, so thank you again for everyone tuning into this one. And I've been getting some great feedback on the other ones, and it's awesome to see everyone or see some people using them and then making their own analysis with them. So it's really cool to see that, and can't thank you enough for that. So yeah, I thought since we did a shot charts in basketball the other day, and the second one we did some Premier League data, I thought that a heat map would be pretty cool, um, awesome, and visually pleasing. Sometimes, if you, I've seen a bunch on Twitter, and these are kind of just some that I've made throughout my time, and figured I'd show you guys how to do that and kind of customize them a bit. So let's get right into it. Geez, it's storming out really bad right now. So if you hear some thunder, sea lightning, or rain, that's what it is. But so first, I'll just open up all the packages. I believe these are the same ones that we use for the NBA shot charts. So you just load those like always. We could do up here, run current chunk, or shift command return on a Mac does all of them. So now that we have those loaded, similar again to the shot chart one, you need to load in this chunk of code, which is creates the function to what's it called, to create the court. And then yeah, so NBA data is the same exact process. So this time, I'm not going to go into this much for this one, because if you want, go back to the shot chart tutorial, and I talk a little bit more through that if you want more of an explanation. But this time, instead of doing a single game, I'm going to do look at all the shots that Chris Paul has taken so far in the NBA playoffs. So everything is the same except this code we used last time at the end to filter by date or a date. So that gave us that game that he played on that day. We did Kevin Durant's historical game in the playoffs, but this time if we take that out and just run it, this will give us the Suns 2021 season type playoffs. So then we run that, and then here basically just gives us Chris Paul's. I'm not going to spend too much time on this, so I'll run through it all. And I'll end up with a data frame called player. My Wi-Fi. So yeah, here we go. Got all of Chris Paul's event data. There's a shot location right here. There we go. So yeah, now let's get into the heat map. We'll open up a heat map chunk. All right, so this R package called Palleteer, you can use to pretty much find all these color palettes for plots that you want to make. And this goes back, I learned this in Thomas Mock's, what's that? I put a bunch of resources at the end, the links, so you guys can look through them if you want. But this one I learned in his tutorial for heat maps, which this is very inspired by. So yeah, here we go. Basically just gives us a bunch of color palettes, and then here's a guide. I linked this to as well. These are a bunch of ones that you can use in, what do we use? Scale, fill, manual. So we create our own palette here. We use the yellow, orange, red. So I'll come back to this and show you how it works after, but by loading this in the palette, we can make that our color palette and the values for fill and color. But let's get to plotting. So similar to the NBA one, plot court. There we go, that's our court. Now here is what we're doing for the heat map. So genome density 2D filled. So it's basically taking all of the shot locations and taking the what's it called? Like the density of where the locations are or locations where the shots are, and then coloring them. So based on this, we'll have darker areas of red where the most shots are taken, and yellow kind of towards the outskirts where less shots are taken. So we use our player data, which we created up here, the data frame. And then like I went through in the first tutorial, our aesthetics, so X equals X, so our X and Y locations, and then fill equals, this I got from Thomas Mock's blog. It pretty much just fills in like the density. I don't want to go into because I can't explain it as good as he does, so go check that out. And then this is how he contours it, so how he like it customizes it himself. And then this 0.1 to 1, so this basically takes out the part of the heat map that just fills in where the zeros are. So it kind of cleans it up a little bit and makes it a little better. And then alpha, so I can run this and show you guys what this gives us. So there's the heat map. Here again, we're gonna add our palette to it, the yellow, orange, red. But yeah, as you can see, pretty clean looking heat map. And then the alpha is just how transparent or strong it is. So if you go 1, it's too bright. Kind of, I mean, if you like it, but I think it's a little too strong. It overlays the court too much for me. So I go 0.5, halfway in between. You can go lower, you can go in between 0.5 and 1, but I think that's what looks the best, at least in my eyes. And then we add the line of scale fill manual to tell the environment to use our value of our color palette for both the fill and the color. So this will make it look like a heat map in terms, people think red, they think of heat. So there we go. So actually, I lied. We have the density, most populated area is yellow. And then I said I'd come back. So direction equals -1. So it basically flips it from yellow to orange to red to orange to yellow. So if you take out the negative and then run this again, it will flip all the colors. So we have red is the most populated area, or most dense area, and it filters out all the way down from red to orange to yellow. It's kind of your taste, whatever you like. But then I'll show you, you can also do any of these. I like blues, so I'll show you where you, so if we type in capital B blues here, I like to use this sometimes for teams that are blue, colored, their colors are blue. So then if we run that, there we go. So it's like all the way from like a very faded white to a dark blue, and then we could do -1 direction to flip them again. Yeah, so then that's from the faded white to the dark blue. So, I mean, it's all up to what you guys want to do, but that just kind of shows you how you can customize it a bit. There you go. So I'm going to go back to the and then all of the theme stuff and the scale X, scale Y, I go over that in the shot tutorial. So go back, throw it into the P1, and again, how we do the GG draw I explained in the first tutorial. Don't want to spend too much time to be able to do the second one. There we go. That's our final output of what we get. Here's our GG save function to save it to whatever you want to call it. I did CP3 heat map with our dimensions and our resolution. So pretty not simple, but once you get the hang of it and the data collection becomes easier, you can start making these at a much higher rate. Play with the colors a bit, that type of stuff. So it's just another way to look at shot distribution. And yeah, hopefully you guys enjoy this one too. So we'll get into our second part of the tutorial, which is we'll be looking at Premier League data. So we're actually going to be using StatsBomb, which is like arguably one of the biggest data companies in world football or soccer. And they've actually released throughout the past couple of years their own event data to the public, just little bits and pieces. So basically enticing the public to analyze their own data. Obviously, they can't release all of it, which I mean that'd be awesome. You can't do that because it's proprietary and you make money off of it. But so we'll be going through that through their own StatsBomb R package. So we'll download it here. These are all the old, basically ones we use for basketball. So we'll install it from their GitHub here, excuse me, in the library, load the package. And then this one is a package created from FCR Stats that we'll use to create our pitch. So install that library, there we go. Now all of our packages are ready. And then here we'll get our data. So one of the commands from the StatsBomb package is free competitions. So this basically shows, I'll do this so you can see it better. All of the games or all the competitions that they have open data that we can look into. So they have Champions League, a men's Champions League game from pretty much each season since '99 or a few. This is all the messy data that they released that a lot of people have been looking into. But today we'll be looking at the 2018-19 Champions League game, which is actually the Champions League final between Liverpool and Tottenham. So here we will pipe it, filter competition name, Champions League season name 2018-19. So we get this first row based on these two columns. Like that back into competition. So now we just have this one. Then their other command that they have is free matches. So this basically, you put in the competition you selected and it will spit out the data for that competition that you chose. So yeah, Champions League, Tottenham, England, yeah, basically just describing the game. And then the next command, StatsBomb free event. So this is the one that goes in and gets the data from that match. So we only have to use this data frame because there's only one game, but if there was more than one, you have to filter that out. And then you basically just run this. I'll run the whole line. Let's see what this gives us. Takes a little bit to load. Okay, UCL 19. You can name your data frames, whatever. But okay, so this is the event data. See minutes, second, possession, what the action was, pass, ball receive, duel, carry, there's shots in there. What team has possession. I'm not going to explain all this, but you can go through and check it out. There's like, what is there, 120 variables, so it's a big data set. And then this, they just suggest in their guide that, here's the guide. So I linked this in the resources below, but they have their own presentation on how to use their StatsBomb data in R. So go through that for sure. It's really cool. It'll show you how to do a bunch of cool stuff. But they just suggest using this command, which I guess cleans the data. I don't know what it does exactly, but just run it. There we go. Now we have 157 columns and 3,165 rows of data. Now we have just this game. So we have the UCL final. And what we're going to do is look at Liverpool's, all their passes from that game. So we will take, here we go, the UCL 19, pipe it, and filter for team name equals Liverpool, or double equals Liverpool, and then type name equals pass for pass. So this will give us, so basically what you have to do is go through and find what big value or call a pass. Sometimes it's a capital P, sometimes it's not. It could be a little, yeah. So just go in here. This is equal to pass, and team name. So it tells you who the action is for. And I will send that back into a data frame, which is called Liverpool, to keep it simple. There we go. So 326 passes right here. from the game. And so basically we don't want to have any passes that weren't completed. This is where it's a little weird. I think it's at column 55. So this one takes you all the way to the end. This one takes you to the next 50. Yeah, so pass.outcome.name. This basically says what happens to the pass or what the outcome is. So they have incomplete, unknown, which really don't know what that means. Out, so out of play. I think there's another one somewhere, but it's basically not. I think it's like free kick, kickoff. That's what it is. So basically, I'm assuming everything that shows up as an NA is a completed pass. This might not be a perfect reasoning. But that's what I'm assuming. So it's they kind of collected a little weird in the stats or the R data. So what this does is we filter this Liverpool data set for is.na. So it runs through whatever column we put in here, which is the pass outcome name. And if it's an NA, it keeps it. So if we wanted everything in that column or from the data set based on that column that isn't an NA, we would put this exclamation before, but we want to keep just the rows that have that column with an NA. So I'll do that and send it right back into this same data frame so it overrides it. So there we go. We have 202 passes now, which seems reasonable, completed passes from this game. Next, I'm just going to go through the same data set and select only certain columns because I don't really want to look through a data frame with 157 columns. So I'm just going to select, I'm not going to run through all these. You guys can obviously tell what I selected. If you want, you can choose more, choose less, but I think these are good to have for making a pass heat map. And I included shots in here too, in case, who knows, you guys want to do that. But I could also look into that at one point for another tutorial. But I sent this back into a data frame, added a 1 at the end just to differentiate from the two. So we're selecting all of these and sending it back. Now we have this with only 18 variables, which is much easier to look at. So pass length, pass angle, who's receiving the pass. Oh, I actually didn't choose who made the pass. I feel like that would be a pretty good tab. See player.name. Okay. So let's go here. All right, so now you got player name, who's receiving the pass, where the pass starts, where it starts X and Y, where it ends X and Y. So I think we're good here. Now we have the data. Now we'll get into creating the plot. So the same thing as the NBA one. We create our palette with the color we want. I'm using the yellow, orange, red again. You guys can use whatever you want in that guide I have at the end in the resources, but I think just the heat, the yellow, red, really signifies like heat. So I've been using it a ton, so I like it. But yeah, so we have to create our pitch. Now the difference between our NBA one is we created that own function with our code. This command is in the package we loaded from FCR stat. So all we need to do is type the command, which is create pitch, right? And then it has a few things you can edit in there. So grass color, which is basically just the plot background of the pitch. Background color 15, and then line color is white. So run just that to show you. There you go. Change this to, you can see the difference. I like all gray. You can really do whatever. It's a little funky, so like it just does the boxes in grass color, and you got to change both of them to do the whole field. There you go. That's an awful color green, but I would do dark green. But yeah, so then the same, pretty much same thing that we did in the NBA one. Genome density 2D filled. We're doing the density plots, which is basically technical term for heat map. Data equals Liverpool 1. So the final data set that we made with the passes. So you could do a heat map for, I can show you after this, but you could do a heat map for where the passes are played from or where they're received from, or where they're played. So I'm going to do that. So we kind of show where Liverpool were passing to on average or most often. So our X variable is the X location of the end of the passes, and the Y variable is the end of the passes for the Y location. And then I did 0.4 for the alpha for the soccer one or the football one, just because it's I don't know, it looks a little different. So that's what I went with. Like I said, you guys can pretty much do whatever, but this is like the baseline I gave you. So yeah, there we go. That's the basic before we do anything to it. And as you can see, it kind of runs off the field through the lines, which we don't really want, and we have a legend here. So we'll clean that up and I'll show you how to do that. So this theme, legend position equals none, gets rid of this stuff on the right. And then scale X continuous and scale Y continuous. So how StatsBomb or how FCR Stats builds their pitch is based on StatsBomb's data. So StatsBomb's data, the X locations only go from 0 to 80 and Y only goes 0 to 120. So we want to cut this off. So these two commands basically it's telling the plot to cut off this heat map at the ends of the pitch line. So we should have that, and we should get rid of the legend with this code. So there we go. You can see how it basically cuts it off, and we got rid of everything on the right. So this is looking really clean. All we got to do next is add the scale fill manual with the values equaling the palette that we made with the yellow, orange, red colorway. Add that, and there we go. So I switched this one instead of the NBA one. I did direction just equal to 1, not -1. So we got yellow, orange, and then red being the most dense. So just another way to visualize the density of something instead of just looking maybe at a shot chart that we did in the NBA. And then same stuff, we're adding some themes. I'm pretty sure it's the same stuff that we did in my here. I don't think title, subtitle. Yeah, we actually don't know. So I'll run all of this. Oh, and then the labs. So the labels, title equals whatever you want to call it, subtitle. Once again, then you can change this to your name or whatever. I just leave it on there, but we'll run that. And the way it sets up is a little funky until you save it. Like the titles will look weird. So I will come back here and throw that into P1 and then choose draw P1, basically just so it doesn't run off. And I'll run it all. This should save it, and I'll show you guys the final thing after it's saved, which it always the dimensions figure itself out. There we go. So like I said, you can change a colorway, you can change the text color, the text, pretty much with anything you want to do. But once again, I just want to show you guys at least a base, get a base understanding how to do it. Yeah, I think it looks really cool, and you can use this for the shots in the data set. You just have to start filtering for different things. You can do it from where the passes start. So I can change really quick and show you guys. So we need pass end. I believe it's location. dot x location. So basically, it was just Allison and Van Dyke just playing out of the back the whole time, with Alexander Arnold on the right. I actually don't think I watched this game, so couldn't bear to watch it as a Chelsea fan. So it was a lose-lose situation for me. But yeah, so we'll go back and check back to the end locations. But this marks the end of the third tutorial. I hope you guys enjoyed this one too. It's always fun to do this stuff, and I really enjoy it. So once again, I'll throw this code on my GitHub with the examples on there. Make sure to check out McKay's work for sure in Python. I mean, he's a go. Everyone knows that at that stuff. So make sure to check him out. And thanks again to him for having me on the channel. And my Twitter should be in the bio. So if you have any questions or if anything in the code isn't working, feel free to reach out to me and I could hopefully help you guys out. And yeah, I think that's all I got for this one. And also let me know if there's anything specific you guys want to see in the comments. I do have some things I want to think of or I'm thinking of doing next, but by all means, I'd rather do stuff that you guys want to see first. So definitely let me know if there's anything. But yeah, so thank you guys again for sitting through this with me and watching it. And I'll see you guys next time.